My name is Katie Webb, and I'm a recent graduate student in the Department of Soil Science at the University of Manitoba, and I did my work here at the Trace Gas Manitoba research site located just south of the city in Glenlee, Manitoba. This is a long-term research site that was established in fall of 2005, and it uses the flux gradient methodology to determine greenhouse gas fluxes for CO2 and nitrous oxide, which are of course concerned for us in agricultural production, as nitrous oxide is produced from agricultural croplands. Over the years, we've been able to assess the effects of different agricultural practices, such as using reduced tillage methods or incorporating perennial forages into crop rotations, on those CO2 and N2O dynamics. And then recently we just completed a study here on the effects of a fall rye cover crop and a no-till system on those CO2 and N2O fluxes, and currently they're doing research here on enhanced efficiency fertilizers and their effects on CO2 and N2O fluxes. This site runs continuously year-round. We use the flux gradient method to determine our CO2 and N2O fluxes, and we do that by having two air sample intakes which sample atmospheric gases from two different heights, and then we have what are called sonic anemometer thermometers that determined our turbulent transfer coefficient, which is our wind direction and wind speed, and from that we can determine what direction the greenhouse gases are moving in, whether they're moving from the soil into the atmosphere or from the atmosphere into the soil or the agroecosystem. So our research here at Gas Man helps give us some insight into different agricultural practices and their effects on CO2 and N2O fluxes and how it relates to us in agriculture, and how we can manipulate those systems going into the future with climate change, and how we can reduce greenhouse gas emissions that contribute to climate change from agricultural production. This is one of our micrometeorological towers where we use our equipment to determine our greenhouse gas fluxes. We have the two air sample intakes that are at different heights, which determine our vertical concentration gradient, or the difference in the concentrations of the greenhouse gases within the atmosphere. And then we have our sonic anemometer thermometer, which is the claw looking thing, which determines our wind speed and direction, and that can help us to determine what direction that our greenhouse gases are moving in, whether they be into the atmosphere or into the agroecosystem. This is one of the 4 towers that we have at the site. There are 4 fields that are 4 hectares large, and we continuously monitor greenhouse gas emissions year-round from this site, from the 4 towers.
Hello everyone, my name is Kolody. I'm a master's student here at the university working in Dr. Lawley's Farming Systems Lab. And today we're standing in front of the nickel long-term nutrient management study. Now this is a study that's been around since 2008, and it's a pretty big study. It's about 400 meters by 400 meters, and as you can kind of see, it's big. It goes all the way kind of towards those trees. And now there's 4 reps, and each rep has 2 main treatments, and so one of those treatments was a previous perennial stand that has now been converted to an annual stand, and then the other side of the treatment has been just annual cropping the entire time. And then those treatments were split to get you these fertility treatments, and there's different manure sources and synthetic fertilizer under control. And then those treatments were further split into having a soil building treatment and a conventional treatment. So there's a lot of splits, there's a lot of complexity to this experiment, but it makes it a really good place to study the impacts of management on soil health. So my research focused on assessing soil health using soil health indicators from the Cornell Soil Health Test. Now I looked at about 14 different indicators, and I had a bunch of results, and I found that really for the fertility treatment of this experiment, so whether you added solid dairy manure or liquid pig manure, or you had a synthetic fertilizer treatment or a control, had a pretty big effect on these soil health indicators. So right now we're standing in front of the control treatment, and this control treatment's tended to do the worst for the soil health indicators, because you're drawing down carbon, you're drawing down nitrogen, it's always yielding less, and you're returning less to the soil. But for some of the, say, the solid dairy manure treatment, that one scored really high because you're adding in all those nutrients with that manure. That manure has a lot of carbon, which helps feed soil life and does a lot of positive things. And then the liquid pig manure and the synthetic fertilizer were pretty similar. They acted in a similar way. They had quite similar soil health indicator results. So this experiment has a soil building and a conventional treatment. And the basis for having the soil building treatment, well, actually the treatment involves having a cover crop in the fall or in the shoulder season, kind of when the cash crop isn't growing, and that's to provide ground cover and to have active living roots in the soil, which is really beneficial. And then no-till minimizes disturbance, and that's really important for things like soil structure, pore structure, aggregate stability. So with the soil building treatment, you kind of have those two practices, the cover cropping and the no-till, to try and improve soil health. Whereas with the annual or the conventional system, you have tillage and the soil is bare. And so as you can it's hard to see probably in the camera, but there's some significant height differences between these two crops. And I think you're really seeing the benefits of the soil building practices, especially in a dry year, to water conservation and sort of the whole water cycle in soil. And so with that cover crop, you're building pores and you're helping water get deeper into the soil, you're helping infiltration, and then you're also, you have a living mulch, and then you have a kind of more residue, which helps conserve water and act as almost insulation for the soil. So those are some of the big benefits of having a cover crop. Is you're insulating the soil. It's acting as soil or armor, which is really, really important. Having bare exposed soil, like in a conventional system, is really bad because it exposes those aggregates to just the forces of erosion. So you can have wind erosion and water erosion. You can have aggregate breakdown, which leads to surface sealing. And in a small seeded crop like canola, having nice loose soil is really important for emergence because that seed is small, and if you're seeding, get a big rain, that surface gets sealed, that canola is going to have a really hard time pushing up out of the ground because the surface is going to be hard like concrete, especially on these really heavy clay soils, which are very fine, and you can get a really hard kind of thick crust on top. So having that aggregate stability is really important. So on the right here we have the soil building treatment, and that includes the cover crop. And now a cover crop is something like a cereal or a wheat, and the nice thing about a cover crop is it provides this residue, and this residue acts like soil armor and protects the soil from the harsh forces of, say, wind erosion or water erosion. And the reason why you use a cereal cover crop is because cereals are great at scavenging nutrients, so that's another benefit of cover crop. Anything that's kind of leached down deeper, especially your nitrogen or some of your sulfur deeper down in the soil profile, that cover crop will go and try and get that and bring it back up. So common cover crop species are things like, wheat, a fall rye, oats is a really good one because you keep your seed costs down, maybe a barley. So a lot of those cereals are great options for cover crops because they can go get those nutrients, they have good root structures. They also can, with the right conditions and the moisture, they can produce some good biomass and give you the residue you want to have the benefits that you're looking for. So another benefit of having a cover crop and having that soil building treatment is that the cover crop provides competition, and competition is your best tool to use against weeds. So as you can kind of see, this is sort of on the field edge here where there isn't that competition and there's weeds everywhere. But even in season when the crop is growing, that crop is able to shade out the weeds and kind of reduce their ability to produce seed. The cover crop does the same thing when there's bare soil. It shades out or competes with the small weed seedlings that are trying to grow in the spring and the fall.
Okay, well, thanks for coming out and joining me this morning on when we talked about this experiment that was the basis of your master's work. I have a couple of other questions for you, Jacob. One is, we're looking at this canola strip here, and on the left we've got the soil health side, and on the right we've got the sort of the conventional. It's been really dry this spring, and I wondered what your impression is about how the different management affected the canola crop.
Yeah, Martin, thanks for inviting me. So a big thing is that the soil building has the cover crop. There's a lot of benefits to that cover crop. One of the ones you want to focus on is that residue, because that residue acts as an insulation, so it lowers the amount of water lost from evaporation from a bare soil, and it also traps more snow. That's the thing that you got to think about, is how much snow are you actually trapping. So with a bare soil, the snow tends to blow off and blow into ditches and blow onto the roadways, okay. Where with a cover crop, you're trapping that snow, so you're actually getting more water in the spring.
Okay.
So,
okay.
And right now it kind of looks like that soil building side's a little higher. It's been pretty dry out here, so having that extra springtime moisture can definitely help.
Okay. Do you? One of the things that showed up here early is I thought the establishment was better where we had the no-till soil health side. Is that something that you would anticipate in a dry year from that system?
Definitely. I think just in every year, because for some of these smaller seeded crops like canola, they have to push up. The way the seed emerges, the whole cotyledons have to push through the soil. So if you have in a soil building system, you're really focusing on building aggregation, and that's really important in this heavy clay soil that has, it's 70% clay. So if you break down that aggregation, you get good rains, you can almost build like a layer of concrete on top that makes it really hard for that canola to push through. And just evidence of it is all these cracks over the ground. You can kind of see how there's these different puzzle pieces that are sort of like fractured like a fractured sidewalk or a fractured driveway or something like that.
Yeah, okay.
And so when you have that soil building practices, you get the aggregation gets better and you're protecting the soil aggregates, so it makes it easier for the seeds to emerge.
Okay. And what do you think is the biggest contributor to that process, the no-till? Because the left side here has not been tilled, I think, for 5 or 6 years.
Yeah.
And but it also receives a cover crop. So if you were to advise farmers in this area, which of those two practices would you suggest to do first?
You know, that's a good question. I think it depends on your operation. I'd say the no-till because it's simple. You're cutting out a step of tilling. Or the cover crop, you're sort of adding an extra step, and making sure that you get those cover crops can be kind of finicky, but you could also just experiment with both and see it kind of works for you and your logistics and your operation.
Okay. After the drought of 2021, we saw pretty limited fall. We actually saw in this area, which is not a typical no-till area, we saw a lot of absence of fall tillage, right?
Yeah.
And then last year we had a wet year, and there was a lot of tillage in the fall.
Yeah. People
were back doing what they loved, what they typically have done.
Yeah.
Based on those observations and working in this area and on your research, what would you recommend to farmers in terms of whether they should till in the fall or not?
I'd say I think you should avoid it. Sometimes it's hard because if you till in the spring, if you're set on tilling and you till in the spring, you're going to have little bricks of concrete. But the problem is that when you till when it's wet on a heavy clay soil, it creates a whole lot of issues for you. So you really want to avoid tilling the soil when it's too wet, because you can do a lot of damage to soil structure and you can really compact your soil.
Right. And I think farmers are quite familiar with the problems of spring tillage. So they like to avoid it, and there's a lot of direct seeding equipment. But that fall tillage, what I heard you say is you would recommend farmers avoid fall tillage.
Yeah,
even in this area where fall tillage has been traditional.
I think you can till strategically. Say if you have a really big weed problem, like a perennial weed problem, that might be a good time to use tillage. But if you don't have those problems, you can definitely avoid it. I think people just don't want to because it's something they haven't done, and trying new things can be scary, especially because it's all about managing risk. And do you want to do something that you think has more risk or less risk? And you're typically going to stick with what you know. So
okay, would there be any crops that you would really recommend people not till in the fall because they really don't have a lot of residue? Are there other crops that you think, well, if you're going to till in the fall, I would go with that crop? Any suggestions?
Those cereals, I think they, especially something like an oats, where it produces a lot of residue. And if you're thinking for residue management, you have a really great oat crop. Say you get somehow 160 bushels an acre, you have tons of residue. Maybe you could till, because you might not be used to that much residue, and your soil might not be able to handle that much residue, because those microbes actually need to get used to consuming that much residue. It's sort of like a fire. If you add too much wood to fire, you're going to smother it out. Whereas you kind of slowly need to incrementally add wood to get that fire nice and hot. And so that's sort of how these microbes are decomposing the residue.
I love that analogy. That's brilliant. What about if the farmer would have had the straw baled off that oat crop? Would they need to till that then?
I wouldn't till. I think that when you bale that straw, it's a form of residue management. But the problem with baling is that you might get, like last year where it was super wet, straw prices were low and fertilizer prices were high, and you're probably actually having a net loss on those bales because you're removing things like especially potassium and phosphorus. Now around here, potassium isn't that big of a concern, but phosphorus is. And phosphorus prices were very high into the I forget, $1,300 per ton, $1,400 per ton. So you got to be careful when you remove that residue because you're removing pretty valuable nutrients.
Okay. And then what about this crop, canola? Is this something that farmers should be fall tilling? Or is this a crop that, what's your thought here?
I don't think you should fall till because you have that stubble, and that stubble you can, if you straight cut your canola, that stubble stands nice and high, about 6 inches off the ground, and it acts as a great kind of a net to trap snow. And so that's really important. And then that snow also acts as an insulator, so your soil doesn't freeze as hard and it'll warm up quicker in the spring. And that's also one of the concerns I think with some of this heavier land is that people like to till because it gets the soil nice and black and you're drying it out. Whereas if you just do things to prevent your soil from freezing as hard, it's going to warm up as quickly.
Okay.
So it's about kind of thinking about how there's an aspect of heat management almost to it.
Oh, I love that. That's great. That's really important. Thank you for that. And then what about managing chaff on canola? Is that what should farmers do with their chaff?
Yeah, I don't think there's enough to really manage it, I'd say. It's a fairly low residue. I'm just thinking compared to some of these cereals which produce so much residue, I don't think you need to worry too much about residue management with canola. I don't think it's as big of a concern compared to some of the other crops.
Okay, what about chaff spreaders? Would you recommend chaff spreaders on combines?
Yeah, I think getting a nice even spread. Like you also then run into issues if you're putting combines through those weeds, you got to think about that. And so that's where some of these kind of chaff grinders come into play if you have these big weed problems. But if your weeds aren't too bad, definitely spreading and getting a nice even coverage of that residue is really important.
Okay. Well, that's great. And then thank you for sharing both the results of your master's work and also your experience as an agronomist here in this region. Maybe my last question, or just see if you have any final comments you'd like to make, but I guess what could maybe get your thought process started there is when this experiment was started, the soil health side, then we ran into all these dry years. And so, what's the message you have for farmers or agronomists from what we've learned here through this relatively dry, decade that we've experienced?
I'd say just you need persistence. If you're trying something new and it doesn't work 1 year, don't give up on it. Like, just reassess. And is it kind of, what were your goals? You got to set those goals and figure out, well, did you achieve those goals? And if you didn't, maybe reassess and kind of change your strategy. But don't completely throw the practice right out the window. You got to keep on trying. And in these dry years, it's hard because you're probably worried about that cover crop using up water, but it also might be kind of the fact that for those cover crops to have those benefits, it takes 5-10 years, which is not sometimes how the planning goes. The planning might go year to year for your bottom line, but kind of having a longer term plan for your farm is definitely really important, and for your soil, because a lot of these practices, this soil has taken thousands and thousands of years to be created. So to think that 1 year of your practice is going to create tons of changes might be a little bit unrealistic, and you got to think in a longer time frame.
Okay. Well, thank you very much, Jacob, for spending some time with us this morning and sharing your master's research. It's really good. I have Jacob's committee report here. There's all kinds of great data that you did, and so I wish you a great rest of the day.
Thanks for having me, Martin.